All right, welcome back to trigonometry. Let's go ahead and take a look at the next problem here. So this is figuring out arc length, and of course there's an A, B, and C for this. Let's see, we have a Ferris wheel with a radius of 18 meters. That seems important. Let's write that down. Okay, so we have a radius equals 18 meters. Okay, I've got my assistant here. Oh, come here, baby. Oh, there you go. Okay. See, he really wants to help. Actually, he really wants dinner, but we're not ready to beat that for him yet. Okay, where were we? And let's see, radius starts at the lowest point and travels through a central angle of 135 degrees. So we have 135 degrees, and they want to know what is the arc length? How long did the person travel? So we have to go back and we have to say R is equal or S is equal to R theta. However, theta has to be in radian measures. So the first thing we have to do is convert 135 degrees into radians. Okay, so we're going to go ahead and do that. So we have, this is 135 degrees, and we could say what that's going to do for us. I look back up at the previous one, but just in case we forgot, it's 360 degrees is equal to 2 pi radians. So if we divide by 360, I know that 1 degree is equal to pi over 180 radians. Okay, so we're going to say that we have 335 times pi over 180, and that's going to tell me how many radians I have. All right, so we'll go ahead and figure that out in a second here. All right, so let's see. We will have S is equal to R, that's the 18, times the theta, and that's going to be our 135 times pi over 180. Now let's go ahead and go to our calculators so we can kind of figure that out. One of the things I'm going to do is I'm going to say this is 135 as soon as this turns on, 135. Okay, how about 135 divided by 180? And we'll see if we have a nice little thing there. It's 0.75. Hey, go figure. That's 3/4. So that's equal to 18 times 3 pi over 4. 0.75 is 3/4. I didn't do anything with the pi. I just left it there. Okay. So we can go ahead and do that. And we'll say, okay, 18 times 3/4 or 18 times 0.75. So we're going to say times 18 here. And then we have, voila, we have 13.5 pi radians. So this will be 13.5 pi meters that we actually travel through. I think the problem tells us to go to the nearest tenth of a meter. So what we're going to do is we're going to go back to here and we're going to say times pi, second function pi. All right, it equals, and this is 42.4. 42.4 meters. And since they said go to the nearest tenth, that's all we have to do with this one, right? And that's what you do for that problem. Okay, so it's really important to remember the formula. You have to memorize this. RS is equal to R theta radians. Okay, so you have to memorize that. All right, next problem here. So we have a circular running track of radius 42 meters. Okay, it sounds pretty big. During a warm-up, a runner covers an arc that subtends 210 degrees at the center. If the runner's speed was 3.2 meters per second, how long does the warm-up last? Let's go ahead and start dissecting this. So we have a radius of 42 meters. Let's write that down. That seems important too. So we have our radius is equal to 42 meters. And then we are told something about 210 degrees. Okay, so my theta is equal to 210 degrees. We're going to convert this to radians in just a second. All right, and then the last thing we have to do is we are knowing that the velocity the person moves at, the speed, is going to be, what do we have here? 3.2 meters per second. So we're going to say that the speed, I'm going to use V for 3.2 meters per second so we can get how fast this thing happened or how long did this thing take. Okay, so step one, let's go ahead and convert it to 210 degrees. Okay, and we can look at the previous problem and say, okay, that's going to be pi divided by 180. I'm going to leave it as pi's because maybe some things will turn out to be kind of nice. So we've got 210 divided by 180. We're going to go ahead and deal with that first. 210 divided by 180, and hopefully we'll have a nice number. Okay, not really. What I can do, and your calculators will have an ABC button, which I would suggest that you use. So we're going to do math, or we're going to do fraction, and we're going to say this is 210. Oh, wait, no, we're not. We're just going to go ahead and punch that thing in there. Both delete, delete, delete. So fraction to my answer. So we're going to convert 1.1667. It's 76. Um, oh, I didn't like that. Okay, so let's go with, hold on a second. Let me see if I can do this from my thing here. Divided by 180 equals, and we go to math, frac, and it will go ahead and do it that way. 7/6. Okay. Again, your calculators have an ABC button. It will automatically do this, but that's 7/6 pi. All right. And that's my theta. All right. So in order to figure out my arc length now, so we have S is equal to R theta. So that's going to be 42 times 7/6 pi meters. Okay, 42 is 7 times 6. So we're going to say 7 times 6, that's 42, times 7/6 pi. The whole reason I did that was like, oh, look at that. We've got 49 pi meters. 49 pi meters. That's the arc length that we had to go through. Now, what we're going to do is we're going to use this 3.2 meters per second. So we're going to say that we have seconds over 3.2 meters, 3.2 meters per second. The meters are going to cancel, and we're going to say this is 49 pi divided by 3.2. We're going to have to use the calculator. Does it tell us how many decimals we're supposed to use here? How was one blast? It should have had a little thing here. I think I was going to go with a tenth. We're going to go with a tenth of a second. Okay, so we're going to do that. So we're going to go to tenths of a second here. Okay, let me go back to my little guy here. So we would say tenth of a second. Okay, so we could say we want 49 times pi, all right, divided by 3.2, all right, and we'll go ahead and run that through. And this would have lasted for 48 point, let's see what that is, 48.1 seconds. Okay, it's a pretty quick warm up. So there we go for this. Right, that would be my answer for this part of the problem. All right, let's go ahead and look at the next one. So again, we have the tip of a minute hand is 9 inches from the center. How far does the tip of the minute hand travel in 25 minutes? All right, so we're going to say we have a radius of 9 inches. Okay, we have got sharks swarming on me because the cats are hungry. Okay, and then we're going to go through, what do we want to do? We want to go through 25 minutes. Okay, 9 inches, we have 25 minutes. Okay, one of the things that we might want to do is figure out, well, 25 minutes, that's going to be 5 big hand parts around the clock. Okay, and we have to know how many radians this is actually going to be. So how many radians is 25 minutes going to take? Well, there are 12 little hands here. So we have 12 little clock hands, 12 numbers, okay, is equal to 2 pi. So we're going to go ahead and divide. So we have one number is 2 pi over 12 equals pi over 6 as an angle. So every time we go through one of the big parts of the clock, one of the big numbers on the clock, we're going through a pi over 6 radians. We're going through 25 minutes. That's 5 big hands on the clock. So we have 9 inches times our theta, right? That's our R is equal to R theta, or S equals R theta. Okay, so that's going to be S equals 9 for my radius times, and um, I've got 25, I've got 5 pi over 6, because that's what the arc length is actually going to go through. Let's see if we can do a little bit with this. We have 9 is equal to 3 times 5 pi over 2 times 3. That's a fancy way to write 6. We'll cancel out the 3's, so we end up with this is 15 over 2 pi inches. Okay, and again, this is going to say to the nearest tenth of an inch, tenth of an inch. Just keep it to one decimal place. So we're going to be able to say we have 15 divided by 2, which is 7.5. 7.5 times pi, 7.5 times pi. Okay, and that's going to be our answer. So we have 23 point, and we'll go ahead and we'll say that's a 0.56. We want to round it to the nearest tenth. So it's going to be 23.6 inches. So 23.6 inches. And that would be our answer for that third one there. Okay. So let's double check, make sure we got all 3 of these. Yep, we are all set. So well done with that. And we'll go ahead and say thank you very much for watching the video. And I hope I see you in the next one. All right. Take care.